for some applications, especially when used as sights for handheld weapons. Shortcomings of the first-generation tube at the upper left were largely surmounted with the recent introduction of these two second-generation image intensifier tubes. Not only are they lighter and cheaper, but in several respects superior to their first-generation predecessors. Unlike the first-generation tube, which depended for its performance on a complex three-stage amplification mechanism, the second-generation tube is a single-stage image intensifier. This is how it works. As with the first generation, the faint input image strikes a photo-emissive surface, discharging electrons into a vacuum. But instead of the three screens needed to amplify an image, as in the first generation, a single microchannel plate is incorporated into the second generation tube. For each electron entering the perforated glass plate, as many as 10,000 electrons are discharged. The intensified electron image thus created results in an extremely bright picture as it is focused on the phosphor screen at the viewing end of the tube. The development of the second-generation image intensifier tube signified a major advance in the Army's night vision technology. Costs were reduced, increasing the potential of broad Army issue. As for the tube's performance, it is not only 1/4 the size and 1/2 the weight of its predecessor, but it is a much finer optical instrument, capable of registering an image of sharper resolution and lesser distortion. The reduction in tube weight and size is the key to the realization of a long-standing Army goal. It heralded the birth of a whole new family of image intensifier devices, smaller, lighter, cheaper, yet more effective and reliable. The family's firstborn was this second-generation small starlight scope. Compact and easy to handle, it quickly proved to be a more efficient, more sensitive night weapon sight. In addition, it nearly eliminates a problem inherent in the first-generation device, the momentary blinding of the user by light emitted from tracer bullets. The reduction in size and weight is even more significant in the second-generation crew-served weapon sight. Another item that stood to benefit greatly by the second-generation tube is the multipurpose night vision goggles. The head-mounted goggles were designed to give the individual soldier around-the-clock mobility, a capability of performing a variety of combat and support tasks during darkness. The goggles are ideally suited for night driving. They permit the driver a field of view of 40 degrees and a visibility of up to 100 meters in moonlight and 50 meters in starlight at speeds of up to 35 miles per hour, without interfering at all with his driving. The goggles have proven highly useful for the performance of light maintenance in conditions of darkness. Here, the driver is checking for carburetor problems. The night vision goggles are also quite effective in actual combat. In addition to such basic uses as patrol and command missions, the goggles are envisioned to be of great value in the performance of a variety of other nighttime tasks, including air rescue and medical aid. A monocular version of the goggles is the handheld pocket scope. Unity power and 3 power units have been fabricated. It is designed to be used as a personal night viewer for patrol, local surveillance, weapon fire adjustment, and general orientation in darkness. The pocket scope can also be employed to detect enemy use of infrared lights. The lightest in the image intensifier family, the pocket scope weighs 1.5 pounds. It offers a field of view of 15 degrees and produces a clear image at a range of 375 meters in moonlight and 200 meters in starlight. Combat vehicle sights such as this image intensifier, called driver's viewer, are also being developed. This is what the tank driver sees through the driver's viewer at night.